Now we go to example 3. The question asks us to determine if the line that passes through the point 0, negative 3a and parallel to the line given by x equal to 10 plus 3t, y equal to 12t and z equal to negative 3t passes through the xz plane. If it is thus, the question asks us to give coordinate of that point. So now what we need to do is we have to determine the line that passes through point. Here we have here point P0, negative 3a, and this point is parallel to equation of x equal to 10 plus 3t, y equal to 12t, and z equal to negative 3t. So in this case, for this one, when this line that passes through this point parallel to this line means that from this line you can get a vector v. So vector v here is given by ai plus bj plus ck. In this case, we need to identify what is our a, b, and c. So from this vector, we can get here our a. This is our a. 12 is b, and negative 3 is c. So we have here 3i plus 12j minus 3a. So from here we can form a symmetric or parametric forms of equation, which is if I form a parametric form, I have x equal to x naught plus at, which is equal to 0 plus our a is 3, so 3t, y equal to y naught plus bt, which is our y naught is negative 3. This one is y naught, this one is x naught, and 8 here is z naught. So we have negative 3 plus 12t, which is b is given by this 12. And then our z equal to z naught plus cd, which is equal to 8 plus negative 3t. Because here this one is our t. So see here negative 3 means that we have 8 minus 3t. And then the question mentioned that line passes also through the xz plane. Means that when it passes through the xz plane, we have here for xz plane, our y should be equal to 0. If it is thus, the question asks us to give coordinate of the point. Means that here you have to find a coordinate that our line passes through xz plane. In this case, we need to compute our x, y, and z. But before we compute these three values, understood that y is equal to 0 because it passes through xz plane. In this case, when y equal to 0, we can find here our t, which is we have for y the equation y equal to negative 3 plus 12t. So when y equal to 0, we have 0 equal to negative 3 plus 12t. So in this case, you will have here t equal to 3 over 12, which is 1 over 4. Once we got this t, we can substitute this t in x and z equation, which is here we have x equal to this equation. Okay, so x equal to 3t means that x here equal to 3 times 1 over 4, so x equal to 3 over 4. For z here we have 8 minus 3t, so when we substitute t in this equation, we have 8 minus 3 times 3 over 4, which is equal to 8 minus 9 over 4. When we solve this one, we got 23 over. The point that line passes through xz plane is 3 over 4, 0, and 23 over. Now we go to this example 4. The question asks us to write down the parametric and symmetry equation of the line that passes through 2 points 2, negative 1, 3 and 1, 4, negative 3. In this case, we know that our parametric equation is given by general form of x equal to x naught plus at, y equal to y naught plus bt, and z equal to z naught plus ct. And our symmetric equation is given by t equal to x minus x naught over a, and then t equal to y minus y naught over b, t again equal to z minus z naught over C. Means that in symmetric equation, we rearrange such as T become subject. When we need to solve this one, our first step, we need to have a point P, X naught, Y naught, and Z naught. You have these 2 points, so it doesn't matter if you want to choose either the first point or the second point. Here, I choose the first point here, which is I have here my X naught, Y naught, Z naught is 2, negative 1, 3. Step number 2, you need to find a vector V, which is parallel to this line, which is V is given by AI plus BJ plus CK. Why we need to find this vector V? Because we want to have the value of A, B, and C so that we can substitute in our equation. In this case, our V can compute by the second point minus the first point. So we have here 1 minus 2i plus 4 minus negative 1j plus negative 3 minus 3k. So we will have here negative I plus 5j minus 6k. Means that in this case, we will have A equal to negative 1, B equal to 5, and C equal to negative 6. Once we got our point B and also our vector V, we substitute in equation, which is we have for parametric equation X equal to 2 plus AT, so A is negative 1, so minus D. Y equal to negative 1 plus BT, B is 5, so plus 5D. Z equal to 3 plus negative 6, so minus 6t. And then our symmetry equation, our t is given by x minus x naught, so x minus 2 divided by negative 1. And then t equal to y minus y naught, which is y naught is negative 1, so plus 1 divided by 5, which is our b is 5. And then t equal to z minus z naught, which is z naught is 3, so minus 3 divided by negative 6. Now we go to this example 5. The question asks us to find parametric equation for the line that contains the point 1, negative 1, negative 2, and parallel to the vector v3i minus 2j plus 5k. And then we have to find where this line passes through coordinate planes. So now, for the first thing that question asks to find, which is parametric equation, we know that parametric equation in the form of x equal to x naught plus at, y equal to y naught plus bt, and z equal to z naught plus ct. In this case, we have a point P, 1, negative 1, negative 2, and from this vector, we have our A equal to 3, our B equal to negative 2, and our C equal to 5. So here, we can write our parametric equation x equal to 1 plus 3t, y equal to negative 1 minus 2t, z equal to negative 2 plus 5t. And then number 2, we need to find here where this line passes through the coordinate planes. Means that you have to check all coordinate planes. We have 3 coordinate planes. For the first one is xy plane. When xy planes means that our z here will be equal to 0. When z equal to 0, we have a third equation. This is z, which is equal to negative 2 plus 5t. We can solve for this one to get the value of t. From here, the value of t, you can substitute into y equation and x equation so that you can get points where this line passes through coordinate plane. In this case, for our z, we have 0 equal to negative 2 plus 5t, means that t here will be equal to 2 over 5. When we substitute in x, we have x equal to 1 plus 3 times 2 over 5, which is 1 plus 6 over 5. So you will have here 11 over 5. And then y, we have equal to negative 1 minus 2. And our t, we substitute with 2 over 5. So we have negative 1 minus 4 over 5. In this case, you will have negative 9 over 5. Means that for xy plane, we have a point here. For x, 11 over 5. For y, negative 9 over 5. And 0 that passes through coordinate planes. And then for number 2, we need to check for coordinate y and z plane. So in this case, our x now equal to 0. When x equal to 0, we repeat the same thing, but here we substitute x equal to 0 in this equation, in x equation, to get our value of t. So x here equal to 1 plus 3t, means that 0 equal to 1 plus 3t. So we'll got here our t equal to negative 1 over 3. And then we can solve for y and z. For y, we have equation negative 1 minus 2t. So t here we substitute with negative 1 over 3. So we have negative 1 plus 2 over 3. When we solve this one, we'll got our y equal to negative 1 over 3. And then we solve here for z, which is z, we have negative 2 plus 5 times negative 1 over 3. So we have here negative 2 minus 5 over 3, which is we have negative 11 over 3. So that for this second case, which is yz plane, we have here coordinate 0, negative 1 over 3, and negative 11 over 3 that passes through coordinate planes. And then for number 3, we have to check here our last plane, which is given by xz plane. For xz plane, our y here equal to 0. When y equal to 0, we repeat the same thing. We need to substitute 0 in y equation, in this y equation. So we have 0, negative 1 minus 2t. When we solve this one, we got here our t will be equal to negative 1 over 2. So now we substitute for this t in another two equation, which is for x, we have 1 plus 3. Our t substitute negative 1 over 2. So we have here 1 minus 3 over 2. You will got the answer negative 1 over 2. And then for z, we have here negative 2 plus 5 times negative 1 over 2. So we have negative 2 minus 5 over 2. So we'll got the answer negative 9 over 2. When we solve for this, means that we got our coordinate point is negative 1 over 2, 0, negative 9 over 2. So now our solution for this question is given by this parametric equation. And these 3 points that passes through coordinate planes. So now the question for this one, what is the difference between the previous? It mentioned that line passes through coordinate planes. Means that for this case, you need to check for all plane, which is we have xy plane, yz plane, and also xz plane.